You probably have really cool 3D data from your simulations or experiments, but when it's time to show it, it ends up as a flat Matplotlib plot or an ugly Excel chart. In this video, I will show you a different approach. We will use a short Python script inside Blender to read a simple text file and turn your data into a 3D scatter plot inside a Blender scene with lighting, camera and materials. So your results finally look as impressive as the work behind them. Let's start with the tutorial. Okay, so let's start with our usual Blender window. Here I have just removed the cube and I have added a couple of lights. Nothing else is here. So let's see how we can start scripting in Blender. This will be a very powerful tool that we will learn today. So here in the tabs, we will find the scripting tab, and we will simply add a new text file here. We can also open something that we have already saved in somewhere, some text file that we have. We will click on new, and here we will just simply paste the script that I will leave here in the description of the video. Here we have our script, and we will just play or hit this button here to run the script. If you see, in less than 1 second, we have already created everything from our scene, and we will be able to visualize it here in the layout, the result of our script. This we have been able to generate in less than 1 second with our Blender Python script. We have some points, we have some clusters with some data, and we see we have 3 planes with the grid, this blue grid and the thick marks and numbers. The numbers will always look at the camera, so that it's always visible. So now let's take a look at the script, where we will explain step by step what the script is doing and how you can use it for your own data. It will be very easy just to modify it in order to extend it also to different kind of charts with some surfaces or bars, everything. This will be our visualizer done in Blender with the scripting based on a CSV file. But first, let's take a look at how the CSV file looks. It will be something like this. This is the one that we are using for this example. We will have the header, we tell the name of each column and the column values. We will have X, Y, Z, and an additional 4-dimensional attribute of each point. This one we will use to give some color on the points. So this will be some quantity that we want to illustrate in our 3D Blender 3D scatter plot in Blender. So now let's take a look at how we can go from a CSV file to the nice graph, to the nice 3D plot that we have generated in Blender just with one execution of a script. So first, let's take a look at how we usually show these kind of results in papers and presentations with Python, with Matplotlib or MATLAB. If you see here in the left side, we see that these charts are very plain and they don't show the three-dimensionality of the chart itself. The beauty of the data is in some way hidden by these very boring charts. With our new Python script in Blender, we will be able to show much nicer visualizations, and we will have a lot of freedom to customize the charts and show it in the most visually appealing and impactful way. This is what we are achieving with Blender and the difficulty that we have, or the complexity that we have for this script is very, very low. So it will be very simple to extend it and to have even different kind of charts just with some small tweaks. So the pipeline of the script will be the following. We will have first part of the configuration, in which we will define all the size of the objects, the number of ticks. We will have all the input parameters that we will use for to create this chart. Then we will show how to use Python to read the data from the CSV and how to process this data so that it can be used properly in Blender. Then with this data that we have imported from Blender, we will go to create the geometry. Here we will be using a geometry node, and here I will also show how to create geometry nodes, not from the usual graphic way to add the nodes as we have shown in previous videos, but with some lines of code in Python. This will be also a very powerful strategy that we will use here. As a fourth step, we will show how to create the frame, so these nice grids that we have created with the axes and the ticks and the labels that will be adjusted of the size of the data. Then we will show how to do the style, the materials, the color that we will give to each point based on each fourth column property. And we will show how to set the camera with some depth of field so that we see the three-dimensionality, or we enlighten the three-dimensionality of the chart with some camera focus and depth of field. I will not show the full script. I will just drop it here in the description of the video, but we will go in this video through the most important lines, also the lines that define the concepts that we will explain in the most important concepts of the script. So let's start with the first block, which will be the configuration. Here we will just define, for example, one line will be for the address or the location of our CSV file. So in my case, I have this directory and the name of the file. We will be able to change also the padding of the axis, so this distance from the number to the axis, the point radius, the grid subdivisions, everything that we can tweak, or all the input parameters will be at the beginning of the script in these configuration knobs. The color range will be also defined, and you have just some violet and orange colors that we can see in our final result. And this will be interpolated as usually with the ColorRamp that we use for the definition of the colors in the shaders. But everything will be done inside the script. The second block is how to import the CSV, or how to read this CSV data with Python. Actually, there is an add-on that you can download and install to import the CSV files into geometry nodes very easily. But in this tutorial, we will not use this add-on. We will build everything by ourselves, and you will also see that in some cases there is no need of the add-on if we know the proper lines in Python. This will be also very, very easy if you don't want to install the add-on, or if you just want to do everything by yourself, so you have control of what you're actually doing. I think it's more direct and clear if you can define how your own data is processed. For example, you can also make some operations with the columns. You can also use it in different instances. You will have more control if you are able to do it by yourself. Also, it will be more adjustable to your own data. This is what I wanted to say. This will be very easy. What we will do is defining a dictionary in Python and then load the rows and the data into some elements of this dictionary. So we will here we will load what we have on each row based on the header of the row, and we will just make one array of points in which we will fill all this data. So this array will contain all of the numbers of the data that we have in our CSV file. This will be everything that we will need to import the values of the CSV into some object that can be used inside Blender. Then with that data, what we will do is define the bounding box of this data. So we will compute the minimum and maximum of each coordinate on each direction. So we will have a cube defined by this x minimum and x maximum, y, z minimum and maximum. We will have the bounds. This will be very useful when we want to create the grid and we want to create the axis. And this will be everything that we will need to import our CSV data in Python. So as you see, it's quite easy. We are already computing some things that we will need in our the construction of our scene without needing a specific add-on. The third block then is the geometry. Now the question is what we are going to do with the data that we have just imported. And here we will create a mesh in which each vertex is 1 point. Then by using the geometry nodes, we will set one sphere or one primitive. It doesn't need to be a sphere. One mesh, primitive mesh in each vertex, as we usually do by set instances on points. So how we do it? We have the vertex. We have defined this each point for the point array that we have defined in the previous step, and we will define this vertex. We will create this vector or with this array of vertices. Then we define the mesh by creating a new mesh that we will call point cloud mesh. Then we use this function that is creating a mesh from the Py data, and we will pass the vertices without any faces or any edges. We will just have a cloud of vertices. That is what we need here, with no connection between vertices, not faces. Then we do mesh update, and now what we have is a mesh that is called point cloud mesh, and then we will have a set of thousands of vertices. Each vertex will be one of these nice points that we'll have on our chart. Last part of this will be normalizing the fourth dimension, what it means that this last column that we have, which will be the value, we will just finding the maximum and then dividing the maximum by range of this value. So this is what we are doing here. We are defining a value t, and the value that we have from the CSV file, we will just subtract the minimum and divide by the range. So we will have at the end a parameter that range from between 0 and 1, and this is what we will pass at the end in our map range of the color, or our color mapping that we will do in the shader. Now what we will do is, as I mentioned, each vertex will be the center of the spheres of these points. So we will create one node that we will call instance, and there will be a new node that will be geometry node instances on points. So here we are creating one node called geometry node instances on points. This is the instances on points node that we already know. We will have another node that we will call object info, and here we will which is just node object info, that will be the input in which we will use this object or this primitive to connect it to the instances on points, and then we will just connect the instance in the socket of the instances of this node that we created. So this is very easy how we access to the inputs of the nodes. So we will have object input, object info dot inputs, and here we will set as instance. So this will be what we will configure, how we will configure this node. We will set as instance and default value true. So we are using what we had, if we imagine the visual geometry nodes configuration, we will have one tick box in which we will get as instance, and we will just set it to true. Then what we will do for this same object, for the same node, the input 0, the input in the 0 position, the default value we will set. So this will be the input of what will tell which will be the object that we will use, and here we will use this sphere object, which is one instance or one primitive, one mesh that we have created, and we are addressing it. Here we are just loading this on the, or we are connecting, or we are choosing this primitive to be the input 0 of this node. Then what we will need to do is just link these two nodes. For that we will use links new, and we will link the output of the geometry, input geometry of the group of the geometry nodes usual set. When we open the geometry nodes, we will have a group input and group output. This will be the group input, so the geometry that we will have, which is actually our mesh. We will link the geometry that is coming out from here to the these node instances on the inputs called points. So here we have instances on points. The geometry we will connect it from the mesh geometry that we created, and the points will be we will connect it to the points, which are the vertices that we will use. And the other link that we will need to do is the object info, which will be this node that we have already created. The output geometry of this node will be connected to the input instance of this node. So if we want to go to Blender, I can explain what we are doing. So let's go to geometry nodes. I think maybe we will be having something here created, but this was not created manually inside the geometry nodes. This has been created from the Python itself, from the Python script. So this is what I'm telling the group input geometry. So this link group input geometry is connected to the input points of the instances on points. So this one, this link. Then the object info output geometry is connected to the instance inputs of the instances of points, which will be this one here. So the geometry output. So here we have the 0 attribute. We have added here the sphere object, and here this one geometry we are connecting to the instances. Then we will have also one part of the code in which we realize instances and connect this geometry to the geometry here. But this you will see it on the script. Now the fourth block will be the 3D frame So which is what we see here. We have the 3 walls, one set of axes, three axes, and some numbers and some thick ticks that we connect to the numbers up to a certain distance. So the grids and this wireframe will be the grid plus the glowing wireframe. We will have we will create one mesh primitive, which will be a grid, and we will add a certain number of subdivisions that we will give as a parameter at the beginning of the script. We will keep one single size that we will scale afterwards based on the bounding box of the data, and we will give some location and rotation also based on what we compute from the data. Then we will just add a modifier, will be lines modifiers new, and we will add a wireframe modifier, which will be this grid that we have, this blue grid. And the wire thickness, we will give it also as an input, as a property parameter that we have defined at the beginning. Then we will just add the materials, and this will be everything for these 3 grids, these planes that we have. Then we will create some axes that will match the data. So we will define 3 cylinders, which each axis here is 1 cylinder. We will give, for example, this will be the axis X, which will be this one here. And we will give the starting and end point of the cylinder plus the radius plus the material, and we will call it axis. So the starting and end point will be X minimum plus some padding, X minimum, X maximum. So here the minimum, here the maximum, and this will be placed just at the maximum of Y, so this will be here, and the minimum of Z, which will be exactly this point. So we will do the same for all the other 3 axes. So we will have here for the Y, we will have also minimum Y, maximum Y, we will have maximum X, and minimum Z. And for this one, we will have it actually from minimum Z to maximum Z, and we will have it not in the maximum X, which will be here in the front of the data, but the minimum X, so that we will put it here. We can also use minimum Y and put it here as we prefer, just left or right. Next part is then computing these ticks and numbers that we have in the chart. For that, what we will do is using the same cylinders or the same mesh to compute, for example, the axis point, the tick end, so which these ticks will be these small marks here, these cylinders, and we will place it in the axis point that we compute here from the axis themselves. So this was we create before, and we will have some location of the label, which will be in a certain X position, which will be for in case of the tick line in X direction. This we will compute from the data itself, how distributed we want the labels, and we will set some the coordinates of the axis plus some offset that we will have for the tick in X and Y. So this is the at the end the length of this tick. So something that we have here, so how far we want it from the axis, and some shift in Z direction that is usually negative, so that we don't have the numbers at the same level of the plane, because this will in some way occlude the visibility of the ticks. And then we just create the tick end and at certain half distance of this distance here. So this is the location of the label, but we will just extend the tick until the half of its distance. Maybe we will see it better in Blender. Here we see our tick marks, and this go until this half of distance between this point and this point. And there is some C direction, C offset to make it more visible. Now the fifth block is the style and the colors, style of the different materials, and the 4D color. So this fourth attribute that we are using as a color in the color of these points. So first, let's talk about this value, mapping it into the color. What we will do is just create the same nodes that we create in the shader editor. We will create it directly in the Python script. For that, we will have the attribute node. We will call it attribute node, and we will add a new node which is called shader node attribute. And in this attribute, we will use the name value. This is the name that we give to this fourth column of the script. Then we will create the node called shader value to RGB, which is the ColorRamp. And then we will just we create this node, and we will just use the low color that we define at the beginning and the high color and the 0 and 1 position of the ColorRamp. This is what we will have. And then simply what we will do is this attribute, this node attribute that we created, we will link it to the ramp attribute that we have. So the output factor, we will input on the factor of the ColorRamp. This we can see. This we didn't do manually, but this can be also seen in the shader editor. If we go here and we select the sphere, so this we need to add that to our sample sphere, and this is what we did. So we create an attribute, we name the attribute value, and we connect the factor with the factor of the ColorRamp. And here we were using the colors that we added at the beginning as input. So this we will see also in our script. Next, then we will need to create a principal BSDF and soft emission for the axis and this glowing blue color that we have on the ticks and the axis. So for this, we then create, we call it BSDF, and we create a new node, the shader node BSDF principal. Then we link the outputs for the color. Sorry, this is still the material for the points, for the spheres of the chart, so the points that we are plotting. We have before we have just linked the input to the ColorRamp. Now what we will do is link this ColorRamp to the actual material, and here we will, for this material, we will use this principal BSDF with some slight emission that we will use for the material. So this link, we will just create this shader nodes BSDF principal. We will link the output that we have from the ramp in the previous step with the input that we have on this node that we create, BSDF inputs base color. So we are just passing the ramp output ColorRamp output to the input here of the base color. Then we will link also the ramp output color to the BSDF input emission. Here there is one mistake. We need to add emission color as well, so that we will add it to the emission color. This will not do anything. The emission will not connect anything. And here on the BSDF input also we will give some default value of the emission strength, which I set to 0.5, which is very slight emission, but this will improve the way in which we see the points if we add some emission. So point respond to light like real objects, but keep small self-glow so they never disappear in the shadow. So this is what I was just saying. And in the same way we will create the materials for the grid and for the lighting axis and so on. But I will show only the material for the points here, so as an example. And you can see in the full script where we define the rest of the materials. Then lastly, I will just define the camera properties and some depth of field so that we have some blur effect that will improve the quality of the render. It will make it look more three-dimensional, and this will be something that of course we cannot do with Matplotlib or with MATLAB when we are doing the 3D scatter plot. This will be the differential point also of what we are doing here with Blender. So one configuration we do, that's that the camera, we just call this variable cam, and here with this instruction we will just use the camera that is already in the scene. Then we enable the depth of field, and we define that the focus object will be our point cloud. So it will be always focused on the data, and the blur will be in the surroundings or even on the axis, but very, very slight. So every time that we run the script, the camera focuses on the point cloud, the depth of field stays correct even if the mesh is rebuilt. So if we run the script again, if we don't do this and we just set the depth of field in the user interface of Blender, when the script is run again, the mesh will disappear or it will be deleted, and then the camera will not keep the properties or will not know on which object needs to be focused. So it's better that we add this here. So every time that there is an object that is called like this, then at the end of the script we will just focus on that object, and this will work better. And that's it then of our script to make it work to different data and make it work with your own data, or customize what we see on the render, what we need to edit. So this will be completely applicable to different kinds of data, different your own CSV file. What we will need to edit is just the path of the CSV file where you have it located, the names, the header of the columns, and of course the look and feel, whatever you want to tweak, the number of axes of tick marks of the padding that we discussed, or the bound radius, the colors, etc. This can be directly added here. So let's go again to Blender. This is what we defined. This is the overall view of the script. As I mentioned, I just describe a small part of the script, but you will be able to see it completely in the description of this video. So we have the sections. So here we have all the configuration parameters, the colors. Here we have some computing the cubes computing the bounding box of the data. Here we have some computation of the ticks, the space between the tick marks and the position of these ticks. Here we load the data, same as we show. We just read the CSV file and allocate this into a dictionary of Python. Then here is the whole section of the materials. We have grid and panel material, we have the glow line material, point cloud, which was the one that we explained. Then the geometry creation. Here we have create point cloud object, create instance sphere. So this will be where we load which kind of object we wanted to use to represent each point. We can be using cubes or whatever we want. Then here we use the instances of points for the geometry nodes. We create the grid panels and the axes, labels, and then the camera part. And this is just the main function when we call everything that we want to create our nice 3D scatter plot. We will take a look again how it looks. And this is what we have. If I took it from the camera perspective, we see that we have very nice field of depth of field. If you want to try this script with your own data, just download the Blender file and the script that I will let in the description of this video. And if you want to go further into Blender and Python for scientific visualization, surfaces, volumes, or animated time steps, hit the subscribe button and activate the notification so you will not miss the next video. Thanks for watching and see you next time.